Hello and welcome to our video on alkenes. We've looked at alkanes and we've talked about alkenes and alkynes, which I will probably add on to this one as well, but we're going to formalize the general formula for alkenes and have a look at how we name them and our semi-structural and structural formulas for them, as well as the properties of alkenes in this video. Let's get started. So alkenes are a homologous series, remembering that this is a family of hydrocarbons that differ from each successive member, only differing by one CH2 group. We've talked about general formulas and we said that the general formula for alkanes, the general formula for alkanes, you may remember, is CnH2n plus 2. In the case of alkenes, we've taken two of the hydrogens out and we've placed in a carbon-carbon double bond. Okay, so all alkenes contain at least one carbon-carbon double bond. If they contain more than one, we tend to call them dienes or trienes. So we're just going to stick to looking at simple alkenes at this point, which contain one double bond. This means that, of course, our first member of the alkene function, homologous series or class of compounds will start at ethene. We don't have methane because we can't have a double bond to only one carbon. So we need two carbons in order for there to be a carbon-carbon double bond. So our first is C2H4, which is going to be ethene. And this will, of course, be a CH2 because we will have put a double bond between the two carbons, which means that we can only have two CH2 groups because the other two bonding positions are taken up in the double bond between the two carbons. So as we go through, we'll end up with propane, butane, pentane, which is going to be C5H10. Hex is our 6, so C6H12. Hept is 7, so C7H14, and so forth, all the way down to decene. So nonene is our C9H18 and C10H20. Of course, we will follow the same pattern for our semi-structural formulas, but remembering that we're going to end up with a CH3 group propping up. If we have a look at propane up the top here, we're going to have 1, 2, 3 carbons, one of which will have a double bond. And then this means we will end up with a CH3 at the end and a CH where it attaches in to the next carbon in the chain. So in this case, we will have the CH2 being at the terminal end of the double bond, a CH in the middle of the chain, and then a CH3. We would have the same. Now we're just going to add a CH2 in the chain. And of course, CH2, CH. Now we're going to have two CH2s and so forth as we go down. Of course, these are all written as having the double bond on carbon 1 of our chain. We do, as with the alkanes, start to see isomers with our alkenes. Okay, so this is just a very brief introduction, and all of these we are assuming would have the double bond on the first double bond. So it would be hep1ene or hex1ene, or what we're drawing the semi-structural formulas here for, because our double bond is at the terminal end, this one, for all of these examples. Up to octane, and then now putting in our 6. So we're now at nonene, and then the last one is our decene. Of course, this is dec1ene, as we were pointing out before. Okay, so when we talk about structural formulas, often, as you'll notice on the previous slide, I find it easier to write structural formulas than I do semi-structural formulas. So I'll often draw the structural before I draw the semi-structural. With this, we have a double bond. So we need to remember that we would have trigonal planar orientation around the carbons involved in the double bond. Okay, so when we get to propene, we're going to have tetrahedral on the terminal CH3. We're going to have trigonal planar around this carbon here and trigonal planar around this carbon here. Remembering that we have no rotation around that double bond, so it fixes it into place. Just going to draw butene this way. Again, remembering to ensure that our carbons 1, 2, 3, 4 all have four bonds around the carbon, okay? And then pentane. Hopefully you are drawing these along with me. Again, I have placed the double bond on position 1 of all of these, knowing that we can form isomers as we saw with our alkanes. So this is what these asterisks are on our pentane and hexane, and of course there should be one on butene as well, to say that we have more than one possible structural formula for these compounds, okay? That there are more ways that we can put them together that meet the general formula of CnH2n and containing one double bond, that we can put these together in multiple ways, showing different isomers. Let's start looking at those. So with our isomers, okay, we are going to think about a couple of things when it comes to having an alkene. First of all, we have our 4 carbons. Okay, as we have said before, we're going to have carbon 1, 2, 3, 4. So if I put my double bond in here, this will be CH2, H, these two here. So there would be this one, which is going to be but1ene. Of course, I can actually move this double bond along. So I can now, if I move my double bond along to be between carbon 2 and 3, so here's my main chain, 1, 2, 3, 4. If I place my carbon double bond between carbons 2 and 3, I now change the structural formula of my compound, but not the molecular formula. In this case, I would have CH3, CH, CH, CH3, okay, which is definitely different to our CH2, CH, CH2, CH3. All I've done is change the position of the double bond by moving it over here, and now I have created the isomer but2ene. Okay, but because there are 4 carbons, ene because it contains a double bond, so it gets the suffix ene, and then I place the number that the double bond is starting on between the 2 parts of the word, so it becomes but2ene. Of course, as we did with the alkanes, I can actually remove one of my methyl groups here and move it into somewhere else in the molecule. So now I can place my CH3 group up here. I still have 4 carbons. I'm going to put in my double bond. So now this carbon has 4 bonds. This one has 1, 2, 3, 4. So we're going to leave him alone. And then we're going to have 3 out here. So now I have 1, 2, 3, numbering from the end with the double bond because it gets priority. I also have a methyl group. This is a 1 carbon group hanging off the chain. So I will now have to start constructing my name. I have bute because it is 4. Sorry. I have 3 in my longest chain, so it will be prop. The double bond is on carbon 1. It has a double bond, so it will be ene. I have a methyl group on carbon 2. So it becomes 2-methyl prop 1-ene for this one here. Have a play around and see if you can come up with any other isomers and have a go at these. Also try writing the isomers for pentene and see how many you can come up with for that.